Assalamualaikum and good day to you all. My name is Siti Karmila and here I would like to present my final year project 1 with the title of Optimization of Material Transportation System in Manufacturing Facility, which is supervised by Prof. Madya Dr. Muhammad Hafidz Fazli bin Fauadi. Here is the slide for Introduction to Material Transportation. Material transportation system is commonly used in a manufacturing facility. It is important to ensure the transportation system is operating efficiently so that manufacturing performance could be increased. This study utilized a simulation approach to evaluate the efficiency of the system. There are few types of material transportation in manufacturing facility. The examples of material transportation is forklift, automated guided vehicle, conveyor, and robot handling system. Optimizing the material transportation has lots of benefits, which is cost reduction, improve the efficiency of the production, and increase the productive capacity in manufacturing facility. There are 3 optimization methods as shown in the tree diagram. The 3 method is simulation, mathematical, and approximate algorithm. In this project, it will mainly focus on the simulation method instead of mathematical and approximate algorithm. Simulation provides an efficient, cost-saving, and environmentally friendly way to develop projects as they remain in a virtual environment until it is built in the real world. There are 3 problem statements for this project, which is current transportation system does not fully optimize in transporting materials. Secondly, ineffective transport planning could affect the whole process in a warehouse. And lastly, the traffic congestion in the logistic and transportation system. If there is a problem, that would be aim or the objective to encounter the problem. So the objective for this project would be to study the current material transportations in the manufacturing facility. Moreover, to optimize the material transportation assignment. The last objective is to calculate the optimal number of vehicles required based on the simulation approach. The scope for this project will mainly focus on the simulation of material transportation system for manufacturing facility, research on automated guided vehicles only, and analogic software used to simulate the structure. The first case used mathematical method and FlexSim software. The objective is calculating the optimal number of AGVs. The other objective is develop system in chosen simulation tool. The table shows the result for this case with different quantity of AGVs. The results state that the most efficient would be 3 AGVs. It has the lowest number of AGV that able to achieve the proper performance. The second case has an objective to increase productivity by choosing the appropriate AGV to handle transportation. There are 2 results, which is productivity and make span. Figure 2 is for productivity result and figure 3 is make span result, which show the optimal number of AGV. Here is the overall flow chart for this project. On the left side is the process that has been completed on FYP1 in last semester, while the right side is accomplished on FYP2. Objective 1 could be achieved in FYP1 by collect data, analyze data, while Objective 2 could be achieved by analyze the result after the simulation approach, and Objective 3 during accepting the results. This is the details for method in accomplishing this project. The step that should be done is dispatching rule, simulation approach, and performance measurement. This table shows the comparison of selected dispatching rule, which is first in first out and last in first out. The first column shows the definition of the rules, while the second and third row shown on the advantage of each dispatching rules. The dispatching rule that has been chosen for this project is first in first out, or we could call as FIFO. FIFO for a warehouse is the most popular method for organizing the warehouse space. The FIFO method introduced efficiency by limiting material handling and minimizing the overall usage of warehouse space. It also the simplest method and follows the natural flow of inventory. This is the flow chart that will be done during the simulation approach from the design AGV system till the result is accepted. On this approach, there will be few of different parameters required for conducting this project. There are 3 performance parameters, which is throughput time, cycle time, and AGV utilization. Throughput time is total elapsed time from start to the finish of a job being processed at one or more work centers, while the cycle time is the maximum time allowed for work on a unit at each station, and AGV utilization is the amount of an AGV's available time that is used for productive work that expressed in percentage. For this slide will be how I run simulation on analogic software. This is the 3D view of the manufacturing facility layout. The AGV moves from one workstation to another to complete the task as I have set up. This is the results that has been achieved for this project. The results that have been achieved are manufacturing facility layout, AGV utilization, system performance, and work in progress. On this slide, it is about the manufacturing facility layout. The top figure, it is the 3D view of the overall manufacturing facility layout in analogic software, and the figure below shows on the process flow of the workstation. It starts with workstation 1 and 2, and then is split by making 3 different products, and finally end with the process with workstation 1. The first figure shows the top view of the layout manufacturing facility, while the figure below is the flowchart that connected with the layout in analogic software. The flowchart consists of 3 lines which indicate 3 processes. The second result is about the AGV utilization. The table on the right has been simplified as the graph on left. The AGV utilization is decreasing as the number of AGV increasing. The AGV utilization is decreasing because the work has been split, the workload with the other AGV. Based on the table of throughput unit of 2 AGVs in FIFO is higher than throughput in LIFO, which has almost similar throughput and AGV utilization with 3 AGVs. The LIFO is not being chosen because the AGV utilization quite higher rather than FIFO, which need to be spared if any downtime is happened. The third result is the system performance for each type of dispatching rule, which is FIFO and LIFO. Data for number of AGV, throughput, and cycle time is compared in the Pareto graph. The system performance will be compared on next slide in choosing the best dispatching rule to be used for the layout. The system performance for dispatching rule has been chosen based on the graph. When comparing the system performance, AGV 2 with dispatching rule of first in first out has been chosen because the throughput unit for FIFO is higher compared to LIFO with the difference value of 42 units. 2 AGV has been chosen instead of the others because the value of throughput for 2 and 3 AGVs is quite similar. Somehow, it is not worth it to use 3 AGVs since it will cost a lot of money, but the output units is also almost similar. For the cycle time, it has significant change in 2 AGVs, which is the cycle time for FIFO is 87.6 minutes, while cycle time for LIFO is 233.8 minutes. The fourth result would be the work in progress for 1 week simulation runtime. Based on the graph shown, as the number of AGV increase, the work in progress is decreased and almost remaining the same. The WIP is higher for 1 AGV because the AGV does not able to complete the task or workload in the manufacturing facility all by itself. 2 AGV has higher number of output rather than the other, but the unit is almost the same, in which it should be considered to be chosen. In conclusion, all the objectives for this project have been achieved as required. The first objective is to study the current material transportation in the manufacturing facility. The objective have been achieved by selecting AGV as the medium for material transport in this project. The second objective is to optimize the material transportation assignment by model the manufacturing flow using analogic software. Utilize variation of dispatching rules to optimize transportation assignment and compare the system performance. The third objective is to calculate the optimal number of vehicles required based on the simulation approach. It has been decided that the number of 2 AGV is the most suitable to be used for this manufacturing facility. That's all from me for this video presentation. Thank you.